Hello everybody and welcome to part 29 of my pre-algebra tutorial. In the last part, ignoring part 28, so I'm going to cross out part 28 because that's not what you're supposed to be watching. You should have watched part 27, which dealt with graphing an equation. So we're going to actually graph an equation to get started with part 29, which I'm going to teach you what slope is. We're going to find slopes of a line with and without using a graph. So let's say we had this following equation. I'm going to just write a random equation. First thing that comes to my mind, plus 4y equals 12. Now, if you did watch part 27 before coming here, I mean, if you felt that you really did understand graphing it and you just wanted to move on, you'd know there's an easier way of solving it if we just isolated y and then used the slope-intercept form. But let's say we didn't do that, which again, if you didn't do it, there's no hassle on you to actually watch it. What I'll do is I'll actually create 2 points, just 2 points required in order to graph a line. And I'm going to show you something cool. Let's say we set x equal to 0. We set x equal to 0. I mean, we're going to plug in 0 plus 4y equals 12. What happens is this 3 disappears, so we're just left with 4y equals 12, and then we get y equals 3. So it's quite simple for us to solve this. In a similar manner, let's say we set y equal to 0, because, who says we can only set x equal to 0? If we set y equal to 0, we get 3x plus 4 times 0 plus 4 times 0 equals 12. Who said we just have to set x equal to a value? We can also set y equal to a value. Doing so, we get a plain x value, and then we get x equals 4. So what did you learn from this? Well, these are 2 very easy points that we can graph. We've basically graphed the intercepts, and we've drawn a line from them. That is going to come up next year. It was just a little trick so I could save a little bit of time with moving on with my recording. So let me actually draw a line that goes through these points, existing forever in this direction. Lines exist forever as long as we touch the 2 points, and then go from here to here and continue on forever, making sure we touch that point and continue on. And now what we've done is we've graphed this equation using 2 points, and we've basically estimated where this line is going to continue. We didn't figure out the points. We didn't figure out that at 8 x equals -3. But when x equals 8, y equals -3. We never figured that out. But based on the way the line tilted, the tilt of the line, we basically made an assumption as to how the line was going to work. Now, that is what slope is. Slope is the tilt of the line. A steep slope, for example, would be a slope, or a tilt that would be steep. So something like this that goes on really high. That's not gonna happen. And a very flat slope, so to speak, would be one that barely moves up. Like by the time I even get to 10, I'm not even at the max most of 1. Now the slope is basically a measurement of how steep or flat your line is. So taking the following equation to figure out the slope, the slope is basically given in the form rise, which means the change in up or down over the run. But if we examine this, we see that the rise, which means how up or down you are, is really measured in the y coordinate. So y, change in y, and in math you'll learn that a change is really given in you had a triangle, then your variable, and a triangle essentially means change. The triangle is actually a Greek symbol that stands for delta. So delta y over run, and run is measured in the x coordinates, so we have delta x. So delta y over delta x. And in order to do this, we're going to figure out how up or down the y coordinate is going, the y coordinate between 2 points. And if you look at that, we already have 2 points. We have this point right here and this point right here. So we're going to examine the slope between these 2 points. And the funny thing about slope of a line, the uniqueness of a line, is any 2 points. Any 2 points. I could go from right here, and I could choose one all the way and close to infinity, and it'd still be valid. We can use any 2 points on a line. As long as they're on the line, we can use any 2 points to figure out the slope. I'm just going to use these two because we figured them out already. So the rise over the 1, the change in y over the change in x. So what I'm going to do now is I'm going to figure out how up or down we go on the y-axis. Well, starting from 3, the y-axis is right here is 0. So at what point does up or down will this point intersect 0? So let's go. 1, 2, 3. It took me 3 down spaces to get to the same to get to the same value as my other point. So 3 down. So what I'm going to write right now is I'm going to draw a little thing. We're going to go 3 down. Well, 3 down is also the same as saying -3. We move down 3 spaces or -3 spaces. Now we're right here. We have to figure out the run still. How far right or left we're going to have to go. So for that I'm going to change colors. I'm going to actually change it into orange. And now I'm going to see how many spaces to the right or to the left I have to go in order to get to x. So I'm going to have 1, I have 2, I have 3, and I have 4. So it took me 4 spaces to the right to get to my other y value. So we're going to write positive 4. So we figured out the slope of our line is -3 over 4. Well, -3 over 4 is -3/4. And slope, the variable that we give slope in math, we can give it really essentially any variable, but a specific variable that almost always deals with slope is m. I have no idea where they decided to use m, but we always use m when we're talking about slope. So the slope of this line is -3/4. Now, that was a really cool method, and granted, this does come up a lot, and, it's very useful when we can use it, but, the chances of you having a graph paper available to you, it's not always the case. So we have to figure out a way that we can relate this graph, but if we didn't have a graph, we'd still be able to solve the equation. And we've figured out a way. So let's say 3x plus 4y equals 12. It's the same equation that we used before. So essentially, we're gonna get that the slope should be -3/4. So just use that as a checkpoint to see if I'm full of baloney or not. But let's say I wanted to actually solve this now. So I wanted to solve this using a pen and paper method. Well, we can do that because we have something called the slope equation, and the slope equation can be used to, well, you guessed it, find the slope. And the slope equation is as follows. It goes y2 minus y1, and I'll explain what all these variables mean afterwards, over x2 minus x1 equals m. And as you learned, m is just a variable we give to slope. So I'm going to draw the table again. I'm going to get a different color actually. I'm going to go for white actually. And I'll just draw an x and y, a simple x and y chart, and we need 2 points. I'll explain why in a second, but why? I get the joke. Anyways, I'll explain why in a second, but take for granted right now that we're going to need 2 points to satisfy this. Well, we already learned that we can just use when x equals 0 and y equals 0, and that gives us a good interpretation for this equation. Sometimes it won't give you a good interpretation, like sometimes it won't clean cut intersect a certain axis. Axes, remember, the 2 lines that we use. Won't exactly intersect one perfectly, might go in between, but for this equation I thought ahead and I used my knowledge to find an equation that would actually do that. So anyways, we have when x equals 0, so x equals 0, we can ignore x, 4y equals 12. I'm hoping you can do this in your head by now. Y would equal 3. Because all you do is in your head you think, well, 12 divided by 4 is 3. 4 times 3 is 12. That's correct. Okay. Now when y equals 0, we could ignore y because it's going to cancel out. So we have 3x equals 12. And divide both sides by 3. That equals 4. So we already have two points that we can use. That we'd use in a graphing method to graph it, but let's say we wanted to use something else instead. Let's say we wanted to use this equation. So the object is to use this equation, and we're going to have to get an answer of 3/4. Let's go. Well, y2 minus y1, basically these subscripts are used to identify different variables. So we have two y values. We're going to need two x values in order to make this work. So we already have those values. We already have 0, 3, and 4, 0. Now, the cool thing about this is they have to match up. We have to make x1 and y1 be inside the same point, and y1 inside the same point, and x2 and y2 in the same point. In theory, we could even have x1, y1 over here, and x2, y1 over here, and we can really flip it around anyway. As long as we keep the x2 and the y2 together, we're fine. So I'm going to actually write an equal sign, and let's plug in our variables. Our y2 is 0, and our y1 is 3. And then we're going to put that over top of our x2, which is 4, minus our x1, which is 0. So now we're going to get, I'm going to extend the page a little bit, and we're going to get 0 minus 3, which is, if you know your negative numbers unit, negative 3, and 4 minus 0, oh, would you look at that, 4. These two correspond with each other. Huh. Well, isn't that thought-provoking? I'm going to want to do one real quickly. I want to think of, I'm going to create 2 points, and you basically understand the slope equation. You guess it's just one of the equations you have to memorize. It's the change in y over change in x, really. Use 2 points, and you just, since the line is linear, it means it increases in gradual steps, we can really use, it's really just a matter of proportions. But you might not understand that, in which case just worry about the fact that it's y2 minus y1 over x2 minus x1. Y goes over top of x. Always, always, always goes on top of over top of x. Otherwise, you can get some really funky answers. So now, let's say I had these 2 points. I want to show something off here. Let's say we had 3, 2, and 4. No, 3, 7, because otherwise this won't work. And let's say I wanted to find the slope of the line, which means the tilt of the line. Well, if we graph these 2 points on here, we see that 3, 2, and 3, 7, they really don't move up or down, but would you say the slope is 0? Well, let's figure this out. The slope is rise over run. So the rise is how far up or down it goes. Well, it goes up 1, 2, 3, 4, 5. Okay, it goes up 5. But the run, how far over left or right it goes up 0. And the problem with 0 is, dividing by 0 is, well, it doesn't freaking exist. We have no number, scientists, mathematicians. You can ask Albert Einstein what 5 divided by 0 is, and he can't give you an answer, so no answer. And this can be proved, this can be found throughout the slope equation 2. Let's say we did y2 minus y1, 2 over x2 minus x1. Well, we get 5 over 0 again, but since the 0 here, the answer is actually something we like to call undefined. It has an undefined slope. And a good way of looking at this is seeing if the x values are the same. If the 2 x values are the same, it will always have an undefined slope. Now, I know what you might be thinking. Let's say the 2 y values are the same. Let's make it 3, 7 and 4, 7 now. So that way, it will be. The x values aren't the same, so it really will have differing value. What we're going to have to do now is, we're just going to have to, we'll graph this actually. We'll graph this actually in this color as opposed to a contrast. So 3, 7, and 4, 7. So this continues on indefinite. Oh, 4, 7 right here. Well, basically continues on indefinitely over here. So the rise, how far up or down it is, it doesn't move at all. It's pretty substantial. So it's 0. However, left to right it goes a bunch. So it's definitely not going to be equal to 0. So because that's the case, you can divide a number by 0. You can have 0 as the numerator, not as the denominator. So that will be the answer of 0. It'll have a slope of 0, which makes sense. It doesn't go up or down at all, so it's 0. We have a flat line, but then we can go up, up, in increments. Anyways, so let me prove that using this, and we can call it a part. y2 minus y1. So I'm going to write y2 minus y1, which is 7, over x2 minus x1, which is 3. So that becomes 0 over 1. And because the 1 is on the bottom, because 0 is on the top, we can actually divide this now, and we get an answer of 0. So I just taught you two new things about lines. Either they'll have an undefined slope, or a 0 slope, or a real slope, or a number slope, I guess. This is true of all real numbers. All linear equations will either have a 0 slope. You can either have a 0 slope, an undefined slope, or a integer slope, I guess. I don't know. I really don't know. Or a number slope, a numbered slope. I guess that's the word, number, not integer, because you can have in between ones. So number slope. So those are the three types of slopes that you can have. That's really all I have for this part. In the next part, we'll look at something. We'll look at examining linear versus nonlinear equations. That will be quite easy and quite fun. See you guys later.